Hey everyone, let's take a look at section 4.2, number 3. We're to simply find the critical points for this function here. Of course, your exponents might look a little different than this. They're both negative exponents. And so remember that this can also be written as x to the negative 14, we 1 divided by x to the 14th power minus 1 divided by x to the 15th power. But I would not write it in that way to find the derivative. This way is much easier. This does help you to see that the domain for this function is all real numbers except for 0, right? If x is 0, we're going to be dividing by 0, which is undefined. And so I emphasize that. So obviously 0 cannot be a critical point. So to find critical points, we need the derivative, and then we are interested in knowing when that derivative is 0 or undefined. So let's take the derivative of this just using the power rule, right? Bring the negative 14 down, subtract 1 from negative 14. So be careful, negative 14 minus 1 is negative 15. And then minus, bring the negative 15 down, x subtract 1 from negative 15 gives me negative 16. And so minus times a minus makes that a plus. I did this two ways. So, basically we want to know now when this derivative is 0 or undefined. It's clearly undefined when x is 0 again, but that would not be a critical point since that's not in the domain. So we do want to know for what value of x will it be equal to 0. So one way I've been fairly consistent in doing it is to factor. I can factor out x to what power? The smaller power, negative 16. So if I factor out x to the negative 16, what am I left with? Negative 14. And this will just be x, because when I multiply these x's, the exponents I'm going to add, negative 16 plus 1 gives me negative 15. And of course, here I'm just left with 15 since I've factored out x to the negative 16. So x to the negative 16, remember, is 1 divided by x to the 16th times this, and we get this as our derivative. Alternatively, you could rewrite negative 14 x to the negative 15 as negative 14 over x to the positive 15. And then similarly here, this would be 15 divided by x to the 16th. Now I find a common denominator, which is x to the 16th. Multiply top and bottom by x here. And now I can add these two together because of the common denominator, and we get exactly the same thing. So either route works. And you can clearly see, again, it's undefined when x is 0, but it's going to be equal to 0 when the numerator is 0, right? When you're dividing into 0, right? 0 divided by something is 0. 0 divided by some non-zero number is 0. So this derivative will be 0 when this numerator is 0. And if we solve that, we get x is 15/14. So that is the critical point for this function. There's only one. Hope this helps on this one.